Hey there, classes, welcome back. Hopefully this video will come out all right. I'm using the iPad today. I forgot my computer at home. So if you check out the still frame behind me, it might be a little bit dim, but we only watched about 10 minutes of the movie Contagion. Now in the movie Contagion, there's Dr. Mears here, played by the actress Kate Winslet. I wanted just to use the beginning where it shows the outbreak, the future pandemic in the movie taking place because we saw so many of the same things happening with COVID-19. It was amazing the parallels between the movie and real life. Certainly the movie is much more dramatic. If you go on through the movie, the plot gets much more convoluted. What I cared about in here was the things that crossed over with our curriculum. In this case, Kate Winslet's character is trying to explain to some health officials the reason they're trying to get ahead of this. She plays a CDC doctor. They talk about the CDC, the Center for Disease Control, and the WHO, the World Health Organization. And we'll just barely touch on some of the social aspects too, because you really can't separate the two. We saw the things in this country happen that were exactly paralleled by this movie that came out about 6 or 7 years before COVID-19. So going into this, she's talking about the R value of flu being 1 on the seasonal level, smallpox being 3. Remember, we talked about smallpox in class. We'll talk about it more with Dr. Jenner. He gets credit for the smallpox vaccine. However, the concept of vaccine had been around for hundreds of years before that, actually. It was one of those science stories where usually one scientist often gets the credit for something that was really a huge collaborative group effort. You're going to see that in 8th grade when you get up to the periodic table. They always talked about Mendeleev in the table, and certainly he played the major role in the periodic table, but it was a huge effort among many scientists. But getting back to this, when you check out some of the things that we saw in the movie, let me kill the screen, I'll bring my whiteboard over here in just a second. The R value has to do with how contagious it is, how many more people are going to get it given one patient. I'm going to go turn off the back screen, just 1 sec. Nope, got it right in my hand right here. And if you look at the numbers that we saw here, the R naught, the R value, you're trying to knock that down below the number 1. If you can get down below 1, that means you're not going to be passing along to more than one person as you move along and try and avoid a pandemic. So those are these notes down here. We're trying to wrap together a little bit about genetic variety with what we saw with viruses, and as we move now into the genetic variety on the larger scale, in other words, larger animals, we're going to be looking at the importance of variety in a population, the importance of mutations in driving evolution. So going here, we are working on mitosis versus meiosis, or meiosis. Both are okay pronunciations. When we're looking at those two, mitosis is for replacement and growth of cells. It's essentially just making a copy. You're making a copy from one cell of all the genetic material. In the case of humans, you're talking about 46 chromosomes. We'll talk about chromosomes later, but you're taking all the DNA and copying it. Meiosis, key point here is that you're making gametes. You're making cells, sperm in the case of males and eggs in the case of females, that have half of the original genetic material. Why half? Well, when we talk about genetic variety, we're talking about it being critically important for mixing the genetic material and getting variety in a population. We've got a silly cartoon on the other side that was designed to get this across. It's a made-up creature. How fuzzy was it? We had some really excellent class discussions about this today, by the way. We'll pull this one over. And if you can imagine a creature, again, simple to draw, it's a little circle, a little bit fuzzy, and it's got a little bit of fur or fuzziness to it that protects it in a mild, say, Mediterranean climate. Let's just say, just for the sake of argument, that this keeps the fuzzy wuzzets just the right temperature through the winters, which are fairly mild in this case. But then something changes in the environment. Remember the Heike crab, that was artificial selection because people were doing it. This would be natural selection because the environment itself is changing, perhaps without human influence. Let's say in this case, the climate grows colder. It can happen for a number of reasons. Think over the very long term, a continent moving. That's why we get into the rock cycle, plate tectonics. Continents do move around our planet, and if you have a continent going from a mid-latitude to a high latitude or exceptionally low latitude, you're going to have perhaps a colder climate eventually in an area that used to be warm if it was near the equator. In the case of climate change right now, humans are doing a very good job of warming up the climate, the biosphere, through our burning of fossil fuels. But for whatever the reason, in this case, the climate grows a little bit colder. Key point here is this: if you have genetic variety, some that are a little furrier or fuzzier, some that are not so fuzzy, not so furry, over a season, the ones that were slightly furrier, slightly fuzzier might have an advantage in survival. They might be able to maintain their body temperature better and survive. It's not a sure thing. It's just a matter of probability. It's a matter of odds. This one might have a little bit of survival advantage, and I'm sorry, but one fuzzy wizard had to die for this lecture. Right here, the one that was by chance not so fuzzy didn't survive the winter. An important point here is this: evolution, change with natural or artificial selection, happens over a population, not an individual. If the climate all of a sudden becomes much, much colder, remember that this individual can't decide, hey, it's getting colder, I better evolve, I better start growing some fur. Doesn't work that way. In other words, we're a victim, or we're tied to our genetic diversity that are in our genes. Now, there was some great discussion with some students, for example, about snowshoe hare. They have evolved to change their color, change their furriness, their fur color. Over the seasons, they're white in the winter to blend in with the snow. They're brownish in the spring, the summer, the fall to blend in with the brush. That's an evolutionary adaptation. Remember also, evolution by natural selection works from viruses all the way up to the big stuff. And that's one of the things that we're talking about in here. That's the importance of genetic variety. Two other things that came up too about the importance of genetic variety, just social tie-ins with Contagion, the movie. They do a good job. We just touched on it barely in there because you really can't, and you don't want to, take apart the social aspect from the biology aspect. We saw in the movie Contagion misinformation, disinformation being put out by some people that were trying to sell, for example, bogus cures. We saw that with COVID-19. We still see that with COVID-19. We also saw Dr. Mears, the character again played by Kate Winslet, that was running up against resistance of people to, for example, close schools to try and bring that R value down. Resistance of people who didn't want to wear masks, for example, also in an attempt to reduce that R value. We saw all of this with COVID-19. In terms of genetic variety, we was just going to barely touch on The Boys in the Boat. By the way, that's coming out on December 25th this year. So if you check out that, I had plugged this earlier. I only mentioned it because this book had popped up once or twice in class in terms of discussion. And remember, the boys from Washington went to the 1936 Olympics. It was a very big deal because the 36 Olympics were held in Berlin, and they were going up against, among other countries, Nazi Germany. And there was this perverted sense, this insane sense really of an Aryan supremacy by Hitler and his followers. And that was one of the things that was touched on deeply in the book. And when we're talking about genetic diversity here, it drives the point home that that's exactly what you don't want. You don't want everyone in a population to be exactly the same based on some preconceived notion of some kind of purity of a race. That doesn't exist for one thing, and for another thing, that would be exactly the opposite of what you would want in a healthy population to survive. You want genetic variety. Genetic variety is a good thing. When we're looking at things like, one other student brought up the term survival of the fittest. Survival of the fittest, again, bringing in some of the social stuff here just a little bit, but students should be aware of this. Survival of the fittest was used, a phrase like it was used by Darwin, but it was also used by industrialists to say, hey, we are at the top of industry, we deserve to make all this money while the workers all make just a pittance to get by, because they were trying to apply Charles Darwin's ideas on natural selection to society, saying, well, survival of the fittest applies to us because we're more fit. We should be at the top of the social hierarchy, while the people at the bottom, if you will, the people who are working 6 days a week, 10 hours a day for 25 cents an hour, they kind of deserve to be there. No, you can't apply Darwinism to society, yet people have tried. So it's important as we go through the biology, as we learn about mitosis and meiosis, it's also important that we remember that a lot of these ideas get incorporated into society, and sometimes people like to kind of change them to their own ends. And the thing about science is you have to be well-versed and you have to really understand the concepts and be able to stand back and say, wait a second, that's how it works with biology. This does not apply to human society. So a little bit of a social tie-in there. And again, we only watched about 10 minutes of the movie Contagion. I know a couple of the local high schools use it all the way through. The plot does get quite convoluted. Again, I used 10 minutes from the beginning. Tomorrow, I'm going to use about 2 minutes from the very, very end, where it shows how the bat DNA mixed with the pig DNA, and then it jumps species. And remember, when a virus jumps species, that's when, especially when it jumps, for example, to humans, that's when you can talk about pandemics occurring. All right, I threw a lot at you today. Check out the notes. They're out there online at pacificascience.org, and a link below that really excellent scene where Dr. Mears is trying to talk to the Minnesota health officials and try and get them on board with the plan to slow down the virus in the movie Contagion. All right, that's where we'll leave it today. Have a good afternoon. Bye-bye.